Now let's define inverse hyperbolic functions and then look at the derivatives and the integrals for inverse hyperbolic functions. So the definition of inverse hyperbolic functions are as follows. The inverse hyperbolic sine of x is the natural log of x plus the square root of x squared plus 1. The inverse hyperbolic cosine of x is the natural log of x plus the square root of x squared minus 1. Inverse tan h of x is 1/2 times the natural log of 1 plus x over 1 minus x. The inverse hyperbolic cotangent of x is 1/2 times the natural log of x plus 1 over x minus 1. Inverse hyperbolic secant is the natural log of 1 plus the square root of 1 minus x squared over x. And finally, the inverse hyperbolic cosecant of x is the natural log of 1 over x plus the square root of 1 plus x squared divided by the absolute value of x. Now hopefully it makes sense to you that since we defined hyperbolic functions over the exponential function, that their inverses are defined in terms of the log function, since that's the inverse of the exponential. Now these 6 formulas are defining inverse hyperbolic functions, much like the definition of our hyperbolics that we looked at the beginning of this section. Those definitions are also stored in the calculator, so you don't need to have those memorized, just like we said we didn't need to have them memorized for the definition of our hyperbolics. What we will be looking at is the derivatives and the integrals of inverse hyperbolic functions. So let's start with the derivatives of inverse hyperbolic functions. On an exam, these formulas will be given. We know that the derivative of the inverse hyperbolic sine of u is equal to u prime over the square root of u squared plus 1. The derivative of the inverse hyperbolic cosine of u is u prime over the square root of u squared minus 1. The derivative of the inverse hyperbolic tangent of u is u prime over 1 minus u squared. The derivative of the hyperbolic cotangent is the exact same thing, u prime over 1 minus u squared. Now just to note, even though their derivatives are the same, they're really different because the domains of the inverse hyperbolic tangent and inverse hyperbolic cotangent are different. For the inverse hyperbolic tangent, the domain is all numbers between -1 and 1. And for the hyperbolic cotangent, it's all numbers from -infinity to -1 and from 1 to infinity. The next two derivatives we are going to be given is the derivative of the inverse hyperbolic secant of u, and that's -u prime over u times the square root of 1 minus u squared. And finally, the derivative of the inverse hyperbolic cosecant of u is -u prime over the absolute value of u times the square root of 1 plus u squared. So we're going to be using these 6 formulas to find the derivative of inverse hyperbolic functions. Let's go ahead and do that for numbers 11 and 12. Find the derivative of the function. So we have that for number 11, y is equal to the inverse hyperbolic sine of 2x. So that 2x there is going to be my u. And since we can't see it anymore, I'm going to go ahead and rewrite it here. The derivative of the inverse hyperbolic sine of u was equal to u prime over the square root of u squared plus 1. Following that formula, knowing that our u is 2x, we get that y prime is equal to the derivative of 2x, which is 2, divided by the square root of 2x squared, or u squared, plus 1. Cleaning that up, we'd get that y prime is 2 over the square root of 4x squared plus 1. Now let's do number 12. Number 12 is f of x equals the square root of 1 minus x squared times the inverse hyperbolic secant of x plus the natural log of the square root of x. Well, the first thing I want to do is recall what the derivative of the inverse hyperbolic secant is. And the derivative of the inverse hyperbolic secant, which is on the page before, is equal to negative u prime over u times the square root of 1 minus u squared. I also want to rewrite number 12 because I know that calculus and radicals don't get along, and anytime I see a radical, I should rewrite it with its rational exponent. So let's go ahead and rewrite f of x. So we're going to say that f of x is equal to 1 minus x squared raised to the 1/2 power times the inverse hyperbolic secant of x plus the natural log of x raised to the 1/2 power. Now before we keep going, we're actually going to rewrite the natural log of x raised to the 1/2 power. Now recall from algebra that the natural log of a raised to the r power is equal to r times the natural log of a. And that's that power to product rule. The power to product rule says that this exponent that the argument of my natural log is raised to can go and multiply the front. So the exponent can go and multiply the front. So we can rewrite this as f of x is equal to 1 minus x squared to the 1/2 power times inverse hyperbolic secant of x plus 1/2 times the natural log of x. So what we've done is we've made the derivative of the natural log a little bit easier because we used that power and brought it to the front, and so now it's just going to be a constant multiplier. Now let's take the derivative here. Well, we notice that we have a product for our first term because we have a first being multiplied by a second. So here we'd say f prime of x is equal to the first, and that first is just 1 minus x squared raised to the 1/2 times the derivative of the second. Well, the derivative of the second follows this formula, which is going to be negative u prime, well my u here is my x, so negative 1 over x times the square root of 1 minus x squared. So the first times the derivative of the second plus the second, and that second is that inverse hyperbolic secant of x, times the derivative of the first, which is 1/2 times 1 minus x squared, raising it to 1 less, negative 1/2, times the derivative of the inside, which is negative 2x. Don't forget about this second term here. So now we have to say plus, and the derivative of 1/2 times the natural log of x. Well, 1/2 is a constant multiplier that multiplies along, and the derivative of the natural log of x is going to be 1 over x. Cleaning this up, we'd have f prime of x is equal to, this can be rewritten as the square root of 1 minus x squared times negative 1 over x times the square root of 1 minus x squared. So we know that these square roots are going to cancel. Here we notice that we have a 1/2 and a 2, so those are also going to cancel. And if we rewrite this without the negative exponent, we would have negative x times the inverse hyperbolic secant of x all over the square root of 1 minus x squared. And then this becomes plus 1 over 2x. Almost done. The only thing left in this first term is this 1 over x. So we have negative 1 over x minus x inverse hyperbolic secant of x all over the square root of 1 minus x squared plus 1 over 2x. Well, we can combine this negative 1 over x and this 1 over 2x. We just need a common denominator. So the common denominator is 2x. Multiplying this first fraction by 2, this becomes 2 and a 2. So 2 to the numerator and 2 to the denominator. So now I have negative 2 over 2x plus a 1 over 2x. So the final answer here would be negative 1 over 2x minus x times the inverse hyperbolic secant of x all over the square root of 1 minus x squared. The last thing in this section are the integrals of inverse hyperbolic functions. the integrals of inverse hyperbolic functions will be given on an exam. We say that the indefinite integral of du over the square root of u squared plus or minus a squared is equal to the natural log of u plus the square root of u squared plus or minus a squared plus c. First, this is always going to be where u is equal to the variable and a is equal to the constant. And that applies for all three of those bullet points. The second thing I want to talk about is the plus or minus. So instead of writing two formulas, we condense it down to one, saying that if you have a plus sign, your answer will have a plus sign. If you have a minus sign, your answer will have a minus sign. The next one, the indefinite integral of du over a squared minus u squared is equal to 1 over 2a times the natural log of the absolute value of a plus u over a minus u plus c. Again, u is equal to the variable, a is equal to the constant. Finally, the indefinite integral of du over u times the square root of a squared plus or minus u squared. Well, that's going to equal negative 1 over a times the natural log of a plus the square root of a squared plus or minus u squared all over the absolute value of u plus c. And again, this has got to be where u is equal to your variable and a is equal to your constant. And as we said before, if you're given a plus sign, your answer has a plus sign. If you're given a minus sign, your answer has a minus sign. For numbers 13 and 14, we're asked to find the indefinite integral. Much like we did when we were looking at the Calculus 1 review and we were trying to find the indefinite integral of inverse trig. For inverse hyperbolic functions, what you want to do is you want to see of the given, which one of these three do they match? They match the first one, the second one, or the third one. Then you find what is a and what is u and what is du, and then you just plug it into your formula. So if I look at number 13 looks like number 3. We know that a is always the number and u is always the variable. So here my a squared has to equal 1. My a is 1. My u squared has to equal 4x squared. So my u is 2x. U has to be on the outside. Is u on the outside? Yes. So I don't need to adjust for anything. And then du is going to equal a 2 dx. But I do not have a 2 dx, so I divide by 2, and 1/2 du is going to equal dx. So remember that 1/2 comes and multiplies along because it's a constant multiplier. So it's going to be 1/2 times negative 1 over a, well, a is 1, times the natural log of a, which is 1, plus the square root of a squared, which is 1. And since our given is a minus sign, we choose the minus sign. And then u squared, which is 4x squared, all over the absolute value of u, so the absolute value of 2x, and then plus c. Finally, just distribute where you can, and you end up with negative 1/2 times the natural log of 1 plus the square root of 1 minus 4x squared all over the absolute value of 2x plus c. Let's do number 14. Number 14 is the indefinite integral of 1 over 9 minus 4x squared dx. Well, if I look here, it matches number 2. So again, I need to figure out what is a, what is u, and what is du. A is always the constant, u is always the variable. A squared in this case is 9, so a is going to equal 3. U squared in this case is 4x squared, so u is going to equal 2x. Now all I need to find is my du. Well, my du is going to equal 2 dx. I do not have a 2 dx, so I divide both sides by 2, and 1/2 du is equal to dx. So then this is going to equal, remember your 1/2 is a constant multiplier that multiplies along, and then times 1 over 2 times a, well, a is 3, and then times the natural log of the absolute value of a plus u, so 3 plus 2x, over a minus u, so 3 minus 2x, plus c. Distribute where you can, and 1/2 times 1 over 2 times 3 becomes 1/12. So we end up with 1/12 times the natural log of the absolute value of 3 plus 2x over 3 minus 2x plus c. That's it for hyperbolic functions.